Hey guys, and welcome back. So at this point in our tutorial series, you've basically acquired a foundational knowledge of how to do functional programming in Haskell. Give yourself a little pat on the back, okay? Feel proud. Now you have the basic tools that you need to go about and do some functional programming, build some simple functional programs in Haskell. So let's take this week to do just that. Build a simple functional program, and what better way to start than to create a game, and what better game than rock paper scissors, the game of kings, the game of true strategists. So how are we going to go about creating our rock paper scissors game? So first of all, let's make this a bit interesting for ourselves. It would be, I think, particularly easy to make the game if it was a two-person player game. If it was a multiplayer game, it would be a bit more interesting to create this game where you have an AI that's capable of implementing different rock paper scissors strategies. So the first thing we're going to do, starting this out, is we're going to model our data, the type of data that our program is going to work upon. So for rock paper scissors, the idea here is that we take turns making a move, and we have three choices in our move. We could move rock, we can move paper, or we can move scissors. Okay, so we'll model this as a data type. If you recall, this is kind of an enumeration type. It's just creating these three new values. And then we're going to have these functions that implement different strategies, which basically means given a list of moves so far, you have to come up with your next move. So this is what the AI is going to use to come up with a new move. So let's just start coding this up. So we have our program model, and let's create some strategies. So the simple strategy, you call this the little brother strategy, is going to be copycat. So we have a strategy. So a strategy is a list of move and returns a move. So what copycat is going to do, let's say if we have empty, we'll just go with rock. Okay, so that'll be our base. If we don't know what to do, we'll just go with rock. On the other hand, if the latest move so far is whatever, we just copy that same move. Okay, so this idea here is that this list of this is previous moves that your opponent has made. So whatever the previous move your opponent made was, you're just going to copy that again. Okay, so that's a simple strategy. What other strategies could we come up with? We could cycle. Okay, so what this idea is going to be that we don't actually even pay attention to what the last moves were. We just move through the same three moves. Okay, so it's kind of like if this is your first time making a move, we'll do rock, and then the second time you'll do paper, and then the third time you'll do scissors, and then we'll go back to rock, paper, scissors. So we'll just cycle through the same moves. So how are we going to do this? So if we want to know which move we're on, okay, what we'll do is we'll take the length of moves. So this is the number of moves so far, and we'll mod that by 3. Okay, and so this will be a number. There's only 3 different scenarios. It'll either be 0. So this is the first move, we'll do rock. 1, this is the second move, we'll do paper. And 2, this is the third move, we'll do scissors. Okay? Scissors. Okay, so this way, we'll just cycle through these same 3 moves. What else can we do? Well, this is my favorite strategy. This is really the king of all strategies. Always rock. Okay, so always rock. Whatever we have, we'll just return rock, because rock always wins. Okay, so now we have 3 simple strategies that we could work with here. So now that we have our strategies, we're going to actually want to define the main game loop. Okay, so the input and output for the game. So to do this, I'm actually going to switch from lib.hs. I'm going to go to app, and I'm going to go to my main.hs file. And what I'm going to do is I'm basically going to want some sort of loop going on where you get input from the player, you figure out what strategy the AI plays, you print out that strategy, you see who wins, and then you loop until the player decides to like quit of some sort. So what I'm actually going to do is I'm going to define a function, play game here, and play game is going to take a strategy, a list of moves, okay, list of moves that have been made so far, and it's going to return an IO, okay? And my main function, this is going to call this play game function. Basically what it's going to do is we're going to call play game, and we're going to give it whatever strategy we want. So let's go with always rock for now. And the list of moves will be the empty list because no moves will have been made so far. And basically this play game, when we write it, it's going to just keep looping until we decide to quit. So by the time play game ends, then it'll be game over. So we'll just print out game over, and then our program will exit, and that'll be it. Okay, so then how are we going to write this play game? This is going to be our game loop. Okay, so play game, like I said, it's going to take a strategy and some moves. Okay, and it's going to be an IO function, so we'll say do, and I'm going to use the curly braces this time, just make, because it's going to be a bit longer, more stuff going on, so just to make sure everything lines up properly. I'll use put str to say enter move. So we call put str, it'll print something to screen without actually printing a new line. And this will be good because after we put enter move, that'll leave there, it'll be left there as a prompt for the user to then input whatever their move is. And in fact, it's probably a good idea to put what the move should be here. It should be either rock, paper, scissors, quit. Okay? So input will be get line here. We'll get input. And then what we're going to want to do is we'll print out put strlen AI plays. Okay, and then the AI will make the move. So you'll enter your move, and then the AI will make a move. Moves. So we'll call this function strategy. So remember, strategy, okay, it takes a list of previously made moves and returns moves. So like always rock, it'll just always return rock. So we give it the moves made so far. Do that. We turn it into a string. We add it to AI plays, and we print this out. Okay. So at this point, the user will have made a move, and then it'll print out what the computer made. Now at this point, you could do some work to be like, well, look up who wins and maybe make a score count or something, but we won't worry about that for now. So at this point, we've got the bare functionality of our game. You make a move, and then the computer makes a move, and then you can just kind of look for yourself who wins. Now, what we're going to do from this point then is decide how to continue playing. So we're going to say case input of, and there's 3 scenarios. So if it's rock, then we play game again, same strategy, but we add rock to our list of moves. If it's paper, it's going to be basically the same thing, except we're going to add paper to our list of moves. And finally, if it's scissors, okay? And then the third scenario is if he enters quit, okay? And we could the easy way to do this is actually is if he enters anything besides rock, paper, scissors, we can just quit. And then we'll do return empty list. So we call, if we want to exit the IO, we have to return something, okay? Some IO. So we'll just return, it's not the empty list, sorry, it's the empty tuple. This is kind of the void value that we can return. So we just say return this tuple, and we're done. and then it'll go back to doing play game. So how is this going to work? So now we're able to, oh, this is missing a do. That's why it was underlined. Okay, so now we're good. So now we could play this game. So let's say we open up a terminal, and this time we're going to load stack app main.hs, okay? And we'll run the main function. We also could have done this through stack run, but we've been using GHCI throughout this course, so we can stick to it. So we enter move, okay? And we have a choice of rock, paper, scissors, quit. And let's try rock. But the AI plays rock. All right, let's try scissors. Oh no, the AI plays rock. I'm pretty sure rock beats scissors. Let's try paper. Okay. Now at this point, the user will probably figure out that the AI is just always playing rock and will just always beat it with scissors. Then we can enter quit, and it's game over, okay, and it goes back to the main prompt. So the obvious problem here is that our game is way too easy, and we did pick the really dumb one of always rock, but if we look at our other strategies here, like even if we picked copycat or cycle, it would only be a matter of time before the user figured out what was going on. It probably wouldn't take them very long, and then the game would just be boring as all hell. So the question is, how do we make better strategies? How do we improve these strategies? So the answer to this lies in something we talked about last time, which is combinators. So the way to make better strategies isn't just to narrow yourself as thinking like, oh, okay, given a list of moves, what kind of new strategies can I come up with? It's the idea that you could take these kind of basic strategies and you can combine them together to make more interesting strategies. So let's take some of these basic strategies, like I said, okay, and let's make some combinators. So a simple one we could start off with is alternate. Okay, so these strategy combinators are going to take other strategies and combine them into a new strategy, hence combinator. So alternate will alternate the two strategies. So this is kind of like the same thing as cycle, except with the strategy now. So we have strategy 1, okay, strategy 2, and a list of moves. And what we'll say is case. So depending on what move we're on, so we'll mod it with 2 now because there's only 2 strategies to pick from. So if we're on the first move, we'll go with strategy 1. If we're on the second move, we'll go with strategy 2. Okay. The confusing thing here, one thing that might throw you guys off here, is you'll notice that this is a function, it looks like it takes 2 arguments and then returns a third. But then when I define this, I give it 3 arguments. I give it this strategy, and then I also give it moves. So keep in mind, strategy here is a list of moves go to move. Okay, so the other way I could have written this is list of moves go to move. And if you look at it this way, list of move goes to move, then this seems to make a bit more sense, right? So just keeping that in mind, it's kind of better to write it this way, strategy, because that is what's going on. Okay, so alternate, that's a good one. Another one is switch up. Okay, and the way switch up is going to work, it's going to take strategy and some moves, and it's going to say case of whatever the strategy is, okay, it's going to switch it up. So if the strategy returns rock, then it actually returns paper. the strategy returns paper, then it actually returns scissors. The strategy returns scissors, then we're actually going to return rock. So we're basically just switching around what the default strategy does. And another one, let's do one more. Let's call this switch down. Okay, so we'll take strategy and return strategy, just like switch up. And the way this is going to work is it's actually just going to apply switch up twice. Okay, so it's gonna extra mix things up. So we're gonna apply switch up to strategy, and then we're gonna switch up whatever strategy switch up strategy returns. Apply that to moves. Okay. Okay, so now we have 3 different combinators that we can play around with. So now we could use these combinators on top of the simple strategies. So we could call these fundamental strategies. And then we're going to use these to define some complex strategies. So here's an example of a complex strategy we could define. Okay, so a complex strategy a complex strategy you could define. What we're going to do is we're going to switch up copycat. So we're going to have copycat but switched up. Okay, so it's going to copy what the person does but switched up, and then we're going to alternate switch down cycling. So we're going to alternate doing switching up the copycat and switching down the cycle. So now if we save this and let's go back to our main program and let's change always rock to our complex strategy. And now we open up terminal. We should run stack build first because we're working between 2 different files here. So run stack build and then let's load this into GHCI again. Oh, okay, app. Okay, and we run main now. Okay, so now we can start playing this game. And in fact, even knowing how this works, oh, we got a non-exhaustive pattern match. So if we look, 3, aha, we screwed up our alternate case here. So this non-exhaustive pattern match 0, 1. Let's change this back and let's save. Okay, that must have been what happened. Okay, good thing we caught that. So let's actually quit and let's build this again. So this is just an example of how easy it is to introduce bugs like that. Let's load into GHCI. Okay, let's play this again. So now we can run rock, paper, scissors. And actually, like you'll notice that even like knowing how this complex strategy works, like even being able to read the code, it's tricky to kind of guess on the spot what's going to pop up. Now, you could really do the work of evaluating like, okay, what was keep track of each of your last moves and then figuring out, okay, what does it come up with now based on what my last moves are. You could figure it out, but it's not that straightforward. And if you didn't have access to the code, it'd be much more difficult to figure out what was going on here. And this is just one example of a complicated strategy you come up with. You could use, and I invite you to play around and use each of these combinators and maybe create some more fundamental strategies, and you could come up with some very interesting rock paper scissors AIs just by using this sort of strategy. So I hope you enjoyed this tutorial. I always think this is a very fun tutorial to do, and I hope you continue to play around and make your own strategies there and try and create the best rock paper scissors game that you can. This is kind of the part where you can really do some interesting things now with your programming ability, just with even just this foundational knowledge of functional programming. Okay, have a good one, guys.